Class, we're going to learn about conversions from atoms and grams to moles, and we're also going to learn about how you can limit a reaction with determining which moles there are of reactants, because if there's not enough to go over, you're going to have some left over and you won't make enough product. So let's begin. What we're talking about is stoichiometry. Stoichiometry is converting grams to moles, atoms to moles. It is also determining which reactant is the limiting. You might want to know what a limiting reactant is. Well, a limiting reactant is something that when the process of the chemical reaction goes all the way to the right, no matter how far to the right it goes, you're always going to have some of another product left over, or another reactant left over, because one reactant does not have enough moles to take all the other reactant and make those products. So, what are we going to learn? You guys are going to learn how to convert grams to moles. You're also going to learn how to convert atoms to moles. You're also going to learn how to balance each side of an equation so that you can use the molar ratio. Also, you will be able to determine which of the reactants are going to limit the amount of products that you're going to get. Okay? These are the academic context standards that us as Ohio teachers have to teach by. Okay, so let's talk about a mole. A mole, some of you guys might wonder why we use a mole as a measurement. Well, you know grams, you know pounds, you know ounces. Well, an ounce of carbon dioxide is not equivalent to an ounce of oxygen. Why? Because it doesn't have the same mass. So you have to take into consideration the mass of an object when you're talking about moles. Well, moles. How big is a mole? Is it small? Is it huge? You know, could you imagine how many baseballs would be in a mole? I mean, it uses those as molecules. Well, a mole is 6.022 times 10 to the 23rd. That's an enormous number. So, if you use baseballs, that's enough baseballs to cover the Earth twice, maybe even 3 times. That number is Avogadro's number. He came up with this when he was studying carbon, and it's the amount of atoms of carbon per 12 grams. So that's kind of what it's based off of. Everything that we based off mole all comes from carbon. All right, so let's talk about how you convert grams to moles. When you're converting grams to moles, you have to determine the gram molar mass. Well, the gram molar mass is determined by the atomic masses of all elements that are in your reactant. So, let's take water for example. Water is H2O, okay? Hydrogen has an atomic mass of 1 gram per hydrogen atom. Well, right here, you can see that there are 2 hydrogen atoms per 1 molecule of water. So, you take 1 gram times 2 hydrogen molecules and you get 2 grams for the gram molar mass of hydrogen just in water. But you also have to take into consideration oxygen. Oxygen has a gram molar mass of 16. So what you would then do is you take 2 grams for hydrogen plus 16 grams for oxygen, and your gram molar mass of H2O would be 18 grams. Okay? That is how many grams of water are in 1 mole of water. So, you might be asking yourself, where do I find this atomic number, this atomic mass? You know, it's not like we can just come up with them out of our heads, you know, you can't make them up. So, you find this on your periodic table. And here it is. There's hydrogen. You might not be able to see this, but it does say 1. It says 1. Now, if we come over here, we have oxygen, and oxygen has a 15.99, but we don't like to use decimals because you don't. How do you have 0.99 of an atom? You don't. You have 1, or you have 2. You can't have 0.99. All right. That's where we find our atomic masses. Next, we're going to show where your gram molar mass that you just found using your periodic table to add all the atomic masses together, where it goes. Well, what you're going to set up is you're going to set up what you're given, okay? So you got what you're given, here's what you're given, all over 1, okay? Well, what do you want? You want moles. That's what you're trying to get. So to get rid of moles, you have your gram molar mass. Your gram molar mass is moles over grams. Shown right here. Okay? And when you multiply 1 mole over the gram molar mass, or your mass that you're given, grams cancel out, and you're left with moles. Okay? That's if you're given grams. If you're given atoms, it's a little bit different. It's not too tricky, but it's the same thing. First, you're given atoms, so you take what you're given and you put it over 1. Then, you do the exact same thing. You're trying to get moles, so moles got to be up top. But what's the conversion rate? That's what we need to know. Well, here's where Avogadro's number comes in. That's the number, 6.022 times 10 to the 23rd. That's the number of atoms per mole. You might want to remember that. So, take the number of atoms you're given, you divide it by 2.0 or 6.022 times 10 to the 23rd, you're going to get the moles that those atoms make up. I have a little YouTube video for you guys. I'm going to skip over it right now. Alright, here's some practice problems. So, let's think about what we just learned. So, what are we given? We're given atoms. So what are we going to have to use? Anybody? We're going to have to use 6.022 times 10 to the 23rd as our conversion rate. So let's set this up. We have 6895 atoms all over 1. Okay? Then, we're going to multiply this by, what are we trying to get? We're trying to get moles. And our conversion rate was Avogadro's number. So, we put 6.022 times 10 to 23rd atoms. Okay? So, atoms are going to cancel out, and you're left with moles. Let's do this math real quick. Okay? We have 6,895 atoms divided by the quantity of 6.022 exp to the 23rd. And we have, anybody have that answer? Yes, that's right. We get 1.14 times 10 to the negative 20 moles of NaCl. Now think about that. That's a lot of atoms right there. That's a lot of atoms. But look how tiny of a mole that is. That's not very much. But if we do this one, we have 467 grams all over one times. How are we going to set this up? We need to put mole up top. What do you think is going to go down in the bottom? Anybody? Gram molar mass. So, what's our gram molar mass? Fe3O4. Well, we go back to our periodic table. Gram molar mass of iron is 55.8. Okay? Right there. 55.845. You can leave it at 55.8. And there's 3 of those. Remember that. 55.8. So 55.8. We do this over here. 55.8. How many irons are there? There's 3 of them. Okay? So by that, times that by 3 irons in that molecule. Okay? And we're going to get 167.4. Now that's just the mass related to iron for a mole. And then we have 4 oxygens. Anybody can remember what oxygen's atomic mass was? 16. So we have 16.0 times 4. And that equals 64. Okay? If you add those up, your gram molar mass, you're given 231.4. Nope. That's grams. Don't forget units. You gotta remember your units, or you can mess up this real easy. Units is key. So grams cancel out. You're gonna be left with moles.